Let's see if we are live. Well, it is a pleasure to be here. I am going to introduce the channel of the century, having hit 100, 1/10 of a million subscribers, 10 to the fifth subscribers, of an amount that I can only dream about at my youthful age of 1 year into this podcasting game. But I've learned so much from Professor Christian Reddy, who is an influence on me and the universe in which I inhabit, always trying to up my game to be even one logarithmic interval of what Chris could do. So I am pleased to announce that we are doing a crossover. Like, remember when well, you're probably too young, but I remember the Facts of Life and Different Strokes, and they would have a crossover episode. So this is a crossover episode of Launchpad Astronomy, where our motto is "Stay curious, my friend," and in San Diego we say "Stay classy, my friend." And it's a great pleasure to be here. Talk about new observatories, talk about some of the great topics you've been on, and maybe look into a mirror of a different kind. Because as I understand it, when you hit 100,000 subscribers, you get a mirrored plaque that you can turn into a telescope. Did you get one yet? Oh, you got to get it out. Yeah, yeah. All right. Just California. Just California's. Yeah, just University of California, San Diego. Yep. Nice. Oh, come on. You got to open it. You got to do the unboxing. Let's do an unboxing. That'll really break YouTube's algorithm, right? Oh yeah. Huh. Look at that. Yeah, it shows it as just fine. I see my sound is up. Interview. Try saying something there. Yeah. Yeah. I'm getting. Uh, maybe is it a settings thing on your side? Because I see I'm
Hello, everybody on the Into the Impossible podcast. I hope you can hear me now.
there. We go.
Okay, I hope you guys can hear me now. We're just waiting. Got a little bit of a delay on your side. Make sure that
Mm,
yes, this is actually live, Jonathan. Um, I hope your folks can. Now we're both muted.
no, that's not true. That's not
Okay,
true at
well,
all. No sound cannot hear the guest. It should be working now. Can somebody? My
and
sound
Brian,
is
your sound is
choppy.
choppy as well. Folks, this is an experiment, and realistically, I don't want to chew up too much of your time. Everybody
Okay.
on Launchpad
Mhm.
can hear me okay. I just
Oh,
want to
now
make
it
sure
says
that we
it's
can
yes
get
working. Okay.
everybody
So
going.
Sebastian, you guys all hear it now. Good now. Okay. You guys can hear Christian. Christian, give me a count to.
Hello, 1, 2, 3. Pi over 2, pi not.
Okay.
How's
All right.
now?
It says
Can hear now. Okay, we have can hear now on Into the Impossible. Yes?
great.
Anyway, let's keep talking and
Yeah.
we'll see. Oh, good. Okay. We got folks, we're good to go. We're back in business. Sorry everybody. Hi, my name is Christian Reddy. Anyway, so Brian, check your comments. You're coming in a little bit low according to your viewers. I think you're
Okay.
coming in
Now I'll
pretty
crank
good
it up.
here.
I'll
Yeah.
crank it up and I'll make it nice and
There
loud.
you go. All
Dragon.
right.
All right.
Yay, look. All right, Lucky Lucy. Hi, good to have you here. We're so glad to have you. And Roka, both Brian and I are using Ecamm Live, except
Yeah.
we just don't know how to use it well. That's all. So
Well, I always say, Christian, it's an experiment, and most of my experiments fail.
exactly. And that's how it always works in science. We
Uh
get
huh.
things wrong all the time. Okay.
Exactly. All right. Good. We are good
Now,
to go.
now that we're good to go. So anyway, as I was saying before, Brian has done a lot of research into the cosmic microwave background, trying to understand, signals coming from the most distant parts of the universe. But what's really, really interesting is that Brian's stumbled across some research where perhaps the background, the cosmic microwave background, can be used to understand, potentially discover something in our comparative local neck of the woods,
Yeah.
i.e., using the CMB to find Planet Nine. Is like, how does this work exactly?
Yeah. So I always say it's going to be really fun to watch the optical astronomers try to measure the cosmic microwave background with their large optical telescopes because now we are horning in on their racket. We are able, with a high resolution instrument such as the my colleagues and friends are building on the Simons Observatory, our large aperture telescope, will have a resolution of about 1 arc minute, which doesn't sound that great compared to, say, the Hubble telescope or JWST or Gaia or something, but it will be sufficient to detect, with the phenomenal sensitivity that we have, anything that's above absolute zero gives off heat. And we can
Hmm.
detect that because it can't be colder than the CMB temperature, which is 2.7265 Kelvin, as all your listeners know. Therefore, a planet which could be at 30 Kelvin is enormously more energetic, more bright in the thermal microwave bandwidths that we can see. And therefore, something like a Kuiper Belt object or something even in the inner Oort cloud could be detectable, in fact, will be detectable, and that includes such things exotica like Planet Nine. So on my channel, I did an interview with my colleague, Professor or Dr. Sigurd Nace, who's at the University of Oslo in Norway, and he gave what I call the journal club. So one of my playlists is kind of like journal clubs. I want people to feel the excitement of being in a university environment with no tuition in their pajamas, as I always say. So there's a journal club episode with him talking about the prospects for detecting Planet Nine, and I also had on Konstantin Batygin, who is an astronomer at Caltech, a professor there. He does planetary science. He's a theorist, so he's not using telescopes. But we talked about the prospects for such objects to be detected, much the same way that the planet Neptune was detected by
Hmm.
Leverrier, essentially predicting based on the gravitational influence of some unseen form of dark matter, i.e., a planet that had hitherto been undetected. So exactly the same types of techniques are very complicated because it's the three body problem, it's the infinite body problem. Solving
Right,
that
right.
is notoriously difficult, drove Newton mad. And
I think he was
I
already a
always,
little mad to begin with, but
yeah, I'm
yeah,
gonna bring
yeah.
out my finger puppet. There we go. Don't make me bring out my finger
Ah,
puppets.
there you go,
Um,
man.
someday you'll have one. We'll have one for Christian. So yeah, so we're able to detect it. We believe if it has a wide variety of different parameters that are expected from such an object in the outer solar system. So we'll be able to do that. And as I say, I'm throwing down the gauntlet to my friends in the optical astronomy community. Can you measure the CMB at optical wavelengths? That is not technically impossible, I guess. So yeah, and anything that gives off heat is detectable. And a challenge that all astronomers are facing, but more so in the CMB community, is the problem of these mega constellations. These satellites that are providing internet coverage to millions, perhaps billions around the world. And it'd be great if they were using it to like beam to our friends in Cuba right now, give them some free internet, Elon. Do your cosmic duty, but I don't know if that's happening. But anyway, these mega constellations are above absolute zero. Therefore, they emit microwave
Right.
radiation. Therefore, they can contaminate our measurements. And that's a big challenge because in the optical, as bad as they are, they can be painted black and, like the Rolling Stones would advise us. But you can't paint on some coating that absorbs and fails to emit any microwaves. Such a thing violates the laws of thermodynamics. So it's a big challenge to us. And I know you've thought a lot about this on Launchpad. What's the latest with this in terms of the optical astronomy community? And maybe we can kind of join forces with optical astronomers and microwave astronomers.
Yeah, no, it's a really that's a very important question. I mean, obviously, ever since SpaceX really got the ball rolling with the first ever mega constellation. I mean, multi-satellite constellations for communication goes back to Iridium, right? But that's just a comparative handful of satellites for satellite telephones. Now we're talking tens of thousands of satellites, spacecraft, just from SpaceX. That's not to be confused with Amazon's, I believe it's Amazon's OneWeb. Then there's the Kuiper program. Then there's China wants to do one of these things. We're talking about a lot of sats out there. That's a huge problem, and it's not just a problem for optical but also for radio astronomy. So anyway, when SpaceX did their first launch back in back in 2019 is when they did their first launch. I mean, the astronomical community immediately took notice, and they were like, "Oh man, we have a serious, potentially very serious problem here," and they organized a conference called SatCon One because I knew they were going to have to do this more than several times. They just got done this past week. They just wrapped up SatCon 2. Okay, hey, progress. We've had two satellite conferences. Now, the thing about this is that they've got participation not just from the astronomical community, but actually from some of the satellite providers themselves. Apparently, there was representatives from SpaceX, from Amazon, from AT&T there. All these folks who actually do want to get involved because they're actually not trying to destroy the night sky. They're just trying to make money. I mean, that's really what this is about. But many of them actually like the night sky as well, and it's quickly become it's not just an issue just in astronomy, but also there's cultures. There's do citizens really want to have the night sky taken away from them? And in some sense, it's kind of like reverberating a little bit to say, oh yeah, you know what? We're also polluting our skies with visible light. What can we do about that? Okay, so what can they do about that? Well, it comes down to several different working groups. I mean, that's what we do, right? We form committees, we form working groups, and we basically try to tackle like one slice of the problem. And while there weren't any definitive solutions announced, there's actually going to be a proper report coming out in September. But they wanted to do a presser just to kind of put a bow on this week. And what they realized, what they were encouraged by, I mean, I do want to say encouraged, was the fact that yeah,
Mm-hmm.
people, providers really are legit concerned as well. They want to do what they can, and I'm just looking at my notes here as I'm talking to you, so I'm going to go ahead and try to do this. Well, they got to do a few working groups. One is figuring out how can we solve this problem, because guess what, you're not going to solve the problem by getting rid of the satellites. Okay, they are not going away. They are
Right.
going to make money, and at the end of the day, there's nothing we can do to stop them. They've got the money, they've got the power, they've got the lobbying. They're going to they're going to have the sky swarming with satellites. The trick is, can you make them faint enough such that they will not interfere with astronomical observations, and can you also make them faint enough so that they won't even interfere with just naked eye observations? The second problem is actually much easier to solve, right? Because the human eye can only see down to basically, under the best of circumstances, down to about magnitude 6. So think about the brightest star that you see at night, and then think about the faintest star that you could possibly see at night. That's a magnitude range from very roughly 0 to 6, and it works out to like a factor of, roughly 100 or so in brightness. That's all fine, well, and good. The problem is that with faint objects in the sky, and guess what? There are a lot of faint objects in the sky. We are struggling to make observations to the very faint objects, because now when a spacecraft passes across the field of view, you're outshining your target by about a factor of 1 billion. Okay. This introduces light into the image or into the spectra that completely buries the signal. So what did I say earlier? We're not gonna get rid of the satellites. We got to software and hardware our way out of this. So the two things are that, okay, there needs to be a very accurate database put together. Something called SatHub is what they're calling it right now, and this would be a place where astronomers can go just to find the latest ephemeris, which is basically kind of like a table, if you want to think of it that way, or a computation of like where a given spacecraft is going to be over your location, and when it's going to be there, and how long it's going to be there, et cetera, et cetera. Designing your observations around that, right? We need software to help us do that. Now, if you've got so that's one of the software fixes. The hardware fix comes in next, because the second I should say this. The second part of the software fix is, what can the software do to help us in post production, to help us weed out those crummy signals and leave us with our data. But again, there's only so far you can get with software fixes, right? You can't reinvent data, you can't make up data. There's no point in doing science if that's all you can do. So you now need hardware fixes. You got to have like auxiliary cameras looking like adjacent to your telescope to give you warning when to stop your exposure, when to stop taking data, let the satellite pass and start taking data again. There's going to have to be an awful lot of these kinds of software and hardware fixes.
Yeah.
Yeah, and this is not exactly easy to do. I mean, this is something that the Satcon folks have certainly recognized. This is a serious challenge,
Mhm.
but if they can get providers to work with them on this, it can go a long way. The question is, can we get people like China to work with us on it and things like that? So, yeah, many challenges. And by the way, just as a final thought on this, if you are dealing with some of like the big huge observatories like the extremely large telescope, the giant Magellan telescope, even Keck and so forth, they got really narrow fields of view. You know what? They can manage, or they should be able to manage. It's when you're dealing with the Rubin survey telescope and the Fritz Zwicky survey array and things like that, these wide fields of view, you've got a serious challenge on your hands. And basically the
Mhm.
Rubin folks are saying, look, forget it, there's nothing we can do about this except stagger our exposures a little bit, and then try to like you know you know cancel off the crummy uh photo bombs by the satellites as best as we can. So it's
Yeah.
it's it's going to be tricky, very tricky.
What about like the prospect of advertisers and folks on my channel are thinking about, can you make, we've seen these images of, IBM drones flying around with the IBM logo and so forth. What about, and I even heard, using the moon as a giant billboard with laser light shows, as if we didn't have enough to worry about.
Good.
When we're not, busy suppressing aliens and so forth. But tell me, like, have you heard anything about that? Like, is the sky off limits for advertising, or is it still, could it be open game for Amazon Prime?
Nothing came of it in today's press conference, so I honestly don't know if celestial advertising is a concern. I think right now this is more like, okay, what can we do just from like the night to night sort of thing? But you're right. You know, companies are allowed to pollute in oceans and lakes and so forth. Hey, why not? Why not paint Eat at Joe's, in oil on top of the ocean. Um,
And then set it on
and then being
fire like they did
Yeah,
recently.
exactly, light it up. Well, obviously they can't do that, right? At least they're governed by net, domestic and international laws and things like that, and that's where it's going to have to come into. There's going to have to be a lot of international cooperation. As a matter of fact, Bez was asking, what is the challenge of China working on this with us?
Mm,
And as far as I know, and Des, don't put, I can only tell you what I happen to have heard so far because I wasn't actually at this conference. Doesn't seem like China's involved in the conversation right now,
hmm,
and getting through to them is a bit tricky
yeah.
because they don't want to be as involved in the
Right.
conversation. I don't know, and I hope I'm wrong. I really do. I would be very glad to be wrong about that. So, yeah. So when you're trying to seek out, make observations, you were asking Brian originally. What got me off of this rant here was that, how do we do this? Can we join forces with the radio uh, astronomers? Yes, I mean clearly there's common cause here, right? We have, fortunately the radio community is already has there are bands of the RF spectrum that
Yeah,
are reserved for astronomy, but you know what? Astronomers aren't all of nature does not broadcast in these very discrete, safe, uh, radio bands. Nature broadcasts in all these bands.
that's right.
So you want to be able to do your science anywhere you need to. They want to be able to broadcast wherever they want to. So yeah, this is definitely leading to some common cause with
Well, now let's talk about some of the future observatories that'll be, some of which will be far beyond the orbit of these low Earth or intermediate Earth orbits. So, in particular, you've done a lot on your channel with the JWST, and talking about what it will be capable of. I've had less to say about that. So, what's the current status? Is it delayed? Again, month per month, day per day. For a while, it was being delayed, such that it would launch by the time my great grandkids are
uh-huh.
professors. So, what's the status of that instrument? And from your perch near our nation's capital at Towson University.
Oh yeah, yeah. Washington D.C. is right down the road, like an hour and a half. But anyway, um, I don't have any contacts in D.C. on this, but I can say though that the news on James Webb Space Telescope is actually good for once.
Hmm.
Yeah. So there were some recent delays announced, but honestly, folks, they just weren't really the kinds of delays like we saw. I mean, we can go back decades. I mean, look, this thing was supposed to launch originally in 2007.
Yeah.
2007, okay. We're a little bit behind schedule.
Hmm.
Look, they've had to do replans and refiguring this thing. And so when they said that, hey, we may have to delay this thing by a couple of weeks, to me that was like no big deal. But why did they have to delay this by a couple of weeks?
Yeah,
So, okay,
that's true.
it's supposed to launch out of French Guiana on an Ariane 5 rocket. It's actually a really good launch system. It's been working great for, well over 25 years now. Uh, it's got basically the largest, widest launch fairing, and that's the key thing because Webb has to fit. It's a 6.5 meter telescope
Yeah.
and it's a 5.4 meter fairing. So if I've done my math correctly, Webb shouldn't be able to fit inside of this fairing. So you have to fold, got to fold it up origami style, and cram it in there, and even then just barely fits. All right, no factor. They figured it out after a lot of testing, and yes, and after a lot of delays. They figured out how to get it to fold itself up and unfold itself reliably to the point where they're confident that this should work in space. Okay, good news. Then last year on two separate launches, there was this anomalous vibration. When the Ariane 5 launches, the fairing splits open to let the payload escape and all that kind of stuff. And this thing really rattled like more than was supposed to.
Yeah.
And this got the engineers very concerned because Webb is a very fragile spacecraft compared to your typical ComSat, right? It's a communication satellite is, and I know I'm oversimplifying, but it's a big box, it's a big cube with solar panels on it and some antennas. Boom, you're done, no factor, right? And it can, just by the inherent nature of its own design, it's able to withstand a little rattle here and there. That's not the problem. Webb, of course, if you've ever seen it, it's this, or it's beautiful, but man, it's fragile, right? So now they're worried about, wait a second, we got this anomalous vibration. How do we address that? Well, it turns out Arianespace seems to have addressed it. Now, I'll believe it when I see it, and we're supposed to see a launch of Ariane 5 this month, followed by another launch next month, and then Webb would launch notionally no earlier than October 31st.
Mm.
Here's the thing. Webb's got to ship down to French Guiana, right? It's got to be integrated onto the spacecraft. It's got to get ready to go. Arianespace says that yes, Double D, yes, they said that they have fixed the fairing pressure issue. Like I said, we'll believe it when that happens. We're waiting for the flight data to come in. But if we get a good result, then we're going to launch. But that's not going to happen on October 31st. That's almost guaranteed not to
Hmm.
happen on October 31st. That will more than likely have to happen in November, possibly early December. Good news, Webb can launch any time of the year. It's going all the way out to L2, which is the Lagrangian point between the sun and the Earth, and it can go out there anytime it needs to.
First occupied by my namesake, my PhD advisor, David Wilkinson.
There
His
you go.
WMAP satellite, first one ever to inhabit L2 Lagrange point.
There you go, man. First one. So Brian firsts, right? Yeah. So we've got this launch lined up, and even though it can go anytime, they're not going to go anytime. Their window ends in early December. In other words, they're feeling pretty good. They're going to go uh, in 2021, and I am actually cautiously optimistic that's going to happen.
Hmm. And looking at, first of all, let's remind our listeners we're doing a crossover episode. All
We
the power
just
of Launchpad Astronomy with the imagination of Into the Impossible.
with the
So go
finesse,
ahead.
the sophistication, the intelligence of Into the Impossible. Yeah, man.
And you know the number one cause of early mortality is lack of exercising your finger to click the like button, the subscribe button,
Whoa.
and so please cross over and click and subscribe to Launchpad Astronomy. And if you're listening on Christian's channel, he's got my channel link there. Appreciate that. We're trying to break through to the cube root of Christian's
Cross
massive
over
audience, which could fill
into
up
the impossible.
two
Ooh,
Washington football team stadiums.
into the
It's great. And
impossible.
I've been on the show
Damn right.
twice now, and this is the first time. So at the very end, which we have only till the top of the hour, I'm going to ask you my thrilling three final questions, Christian. That I asked 9 Nobel laureates, 3 billionaires, an astronaut while she's floating around in space, and I want to also take questions from the audience. So,
Yeah.
yeah. So before we do that, you also had a really cool recent episode, if I'm not mistaken, about another upcoming instrument in astronomy and cosmology. You want to talk about any other of the great observatories that you've been featuring lately? And
Well, so right now the astronomical community is waiting on pins and needles for the what's called the Decadal Survey. Basically, every year the astronomical community gets together, they compile this great big survey of what they want to accomplish scientifically in the next decade, and that in turn leads to recommendations. Good news, NASA is required by law to consider the decadal survey when planning out their space telescopes and things like that. The decadal survey gave us Hubble. The decadal survey recommended Hubble. It recommended James Webb, recommended Roman. And now there's count them, four amazing observatories that would succeed James Webb. Okay, like among other things, like forget the successor to Hubble. This would be the successor to James Webb. Anyway, long story short, because I do want to get us to some questions, there would be an advanced X-ray spacecraft that would take over from where Chandra is leaving off. Basically, think the same size as Chandra, but about 100 times the sensitivity. So the Chandra Deep Field, for example, which is basically an X-ray image of a deep, long exposure image of the X-ray sky, took them, I think like the better part of a month to complete. Well, Lynx, its successor, could do the job in a day. We're talking a tremendous increase in sensitivity. There's a habitable exoplanet explorer, which would fly a star shade ahead, 50,000 kilometers ahead, which would block out the light from a distant star to reveal the planets going around it and be able to directly image those planets. That's a very exciting thing. There's also the Origins Space Telescope, which would be a general purpose infrared telescope capable of finding those cool gases and probing very deeply into those gas clouds where stars are forming and get the highest resolution image and spectra of those forming stars.
Mm.
Then there's my favorite. Then there's the Large Ultraviolet Optical and Infrared Observatory Louvoir. Imagine something that looks like the James Webb Space Telescope with its hexagonal mirrors, but it's like, whereas James Webb is 6.5 meters, yeah, this one's going to be 16 meters across. Like this would be huge, and best of all, it's optical. It's doesn't have to have these crazy thermal requirements that have made our poor James Webb take so long to develop, because to get that sunshade deployed is such a tricky business. So we are waiting to see which ones. I think they need to. I think they need to recommend all four, but they need to.
Mhm.
They need to get a. They need to get in there and make the recommendation. That recommendation is expected virtually any day now. Seriously,
Mhm.
it's coming soon. So
Now I
I did
mentioned,
do some videos about them,
yeah.
and
Mhm.
yeah,
I mentioned, the space station, which is celebrating its 23rd decade this year.
yeah,
And I did an interview with Jessica Meir 2 years ago, a year and a half ago, and she was on the Into the Impossible channel. You can find that somewhere around here. But last night I read a startling statistic that it's the most expensive thing ever made. It cost $150
station.
billion, the space station,
Wow.
which by my calculation is about 10 LHCs. And someone's asking, Simon Farmer is asking in my chat room, how many ground-based telescopes could we have built using the money from JWST, utilizing the newest adaptive optics, ground-based massive telescopes? Do we need to go to space? So Simon's asking a question along those lines. Are we really, these huge projects, these overwhelmingly large government projects, NASA I mean, what have we gotten from the space station? Where do we, I didn't think it would be polite to ask Jessica while she's floating around in zero G. What the heck have you really gotten for your 100, 10 LHCs? But what do you think about this? And then we should take questions from your audience too.
Okay. Science is science. It's important how we do it. Well, there was a time when somebody discovered this strange form of long wavelength radiation. They didn't know what it was for, what it was doing, but they decided to call it radio. And, scientists being scientists went and looked at some other stuff, right? And who knows how much it costs to discover and figure out how to manipulate radio. I know it didn't cost nearly as much as the station. But you know what? Somebody figured out that there was actually a practical use for radio. You know, and so I I tend to say, yeah, I hear you. I totally understand where you're coming from on the cost concerns. Um, as an astronomer, I could say that, well, there actually is an X-ray telescope mounted on board the International Station, which has allowed us to make the very first maps of a neutron star or a pulsar since it's rotating. And the thing is like we've always had this beautiful textbook description of what a pulsar should be. It's this ultra compact neutron star that's spinning super fast, that's going to have these magnetic poles going up the sides, and it's going to whip around like a lighthouse, right? No, no, it's actually funky. It's really funky. It's got these magnetic field hotspots that are kind of both in the southern polar region, like, which is completely wrong, right, compared to
Mm-hmm.
what we expected a pulsar to look like. So, you know, then we have this other larger question. Okay, fine, we can do science with the station. Why then don't we just do it from the ground? And that's simple. Well, it's a simple answer, but a very difficult implementation. It's a simple answer because there's only some science. There's so much science that you cannot do from the ground. How
Hmm.
many ground-based telescopes could we have built for the cost of the James Webb? A lot, I assure you. Absolutely. There's no question about that. The thing is that they could not do the kinds of science that James Webb can do. The atmosphere obscures our view of the infrared sky. And if we want to be able to actually see the universe expanding into the distance, we have to go into the infrared at very high resolution, and that's something that we can only do from space. You know what I mean? And so it's like the question is like, should we do ground-based telescopes or should we do space-based telescopes? In a perfect world, yes, we should both.
Hmm.
But what helps to make the decisions is what is the scientific payoff going to be, right? These are not monetary investments. We're not going to make money off of this stuff. What is the scientific payoff? That's what drives us into these decisions of what missions we're going to fund.
Hmm. So,
So
hmm.
go ahead.
No, no,
Go
that was,
ahead.
yeah. I think you're absolutely right. I think the limitations of it. You have to draw a line at some point. I had an interview with Dr. James Beecham, who's been on many documentaries and TED talks and stuff like that. He works for the LHC, and he was on to talk about putting a uh, a 11,000 kilometer diameter lunar particle accelerator. So a lunar circular accelerator that he didn't even give the cost. I mean, to give him credit, but you have to dream big, and I pointed out
Yeah.
that in the time since Lawrence up the road in Berkeley built the first particle accelerator, of any size, it was this big. It was 36 centimeters in diameter,
Yeah.
and we've gone to 27 kilometers in diameter, which is orders of magnitude more than going from 27 kilometers to 11,000 kilometers. And so why not think big? But of course, you always have to have a good reason to deploy these funds. And I think in the
Right.
the struggle for my particle physics friends is that there is no natural target for build. It's bigger is better, but that can apply to anything. You could say that for advertising or weapon systems or whatever. So it's always good to have a natural target, which are few and far between, as you know, in most sciences.
Absolutely. And sooner or later there just has to be a decision made, and it all comes down to cost benefit.
Mm-hmm.
What can we do? I've often heard, oh, well, these new next generation of ground-based telescopes, which I know we haven't really talked about yet, but they're going to outperform Hubble. What do we need a Hubble telescope for? Again,
Mm-hmm.
it depends. I always say it basically kind of comes down to what problem are you trying to solve? Are you trying to observe in a specific wavelength, at what resolution, at what level of sensitivity, and you use the best tool for the job. It's like any other craft, you have to have more than one tool in the tool belt.
Mm-hmm.
um, if we could throw everything into space very cheaply and so forth, yeah, sure, I could see us never having to build a ground-based telescope ever again. Forget the Starling problem, we're good to go. Well, guess what? You can't do that. It's very
Right.
expensive, and not only that, it's very complex, right? Ground-based telescopes are easier. They're
Mm-hmm.
accessible. You can go and fix them very easily. You can upgrade them very easily. And that's why we got telescopes that have been like the I mentioned earlier the Zwicky Transit Facility, this survey instrument that has caught, has discovered planetesimals in the outer uh, Oort cloud, or far Kuiper belt. Guess what? It's mounted to the 48-inch Schmid telescope that was built in the 1930s. You know, it's an
Right.
upgrade to an old telescope, and it works awesome. It is freaking
Mm-hmm.
amazing. So yeah, I mean, again, there's, what problem do you want to solve?
Exactly.
And Rokia says, on my channel, or we could meet halfway and fly an infrared telescope in a 747. Funny you should ask that question.
Mm.
Hint for a future live stream. We yes, we do have the Sophia Observatory that is doing some infrared uh, work aboard a modified 747. Um, there's a question here. Let's go ahead and hop around a little bit. First of all, Nicholas Paulson, thank you very much for the super chat. Really do appreciate that. Any news on future plans for Arecibo since the live stream with Dr. Menendez? Yes, Nicholas. There will be a follow-up live stream. I've been in touch with them. I'm afraid I cannot say anything else at this time, except
Mm.
we got a show coming, and I think you're gonna like it. All right, and let's see. Zosk was asking, why is Planet Nine so important? Isn't there a possibility there is more than two planets, medium size, far off Pluto? Brian, you want to take that one since you talked to Constantine more recently than I have?
Yeah, there's millions of objects. The question is, what constitutes a planet, and why are these objects so important? I think what's fascinating to me about these objects is, again, understanding the cosmic chicken or egg questions are always fascinating to me. Which came first, the solar system, or the debris, or the planets? Which came first, the universe or the multiverse? Which came first, the chicken or the egg, or the DNA? I did a video this week about, kind of, does life create chirality, or does chirality, because Christian, as your listeners are some of the most astute in the known universe, as are mine, that all life is predicated on right-handed helix style DNA, whereas all elementary particles, neutrinos, are all left-handed, what we call left-handed neutrinos. And some have speculated that there's some link between those, and it's basically chicken or egg type postulates. I feel that way about the solar system, and to learn more about the solar, did the solar system form, the planets form first, or did the solar system form first, in a sort of more coarse-grained perspective? And then, of course, are there other Kuiper belts? Are there other objects? Could they be responsible for, what my past guest Avi Loeb claimed was an extraterrestrial piece of kit, namely Oumuamua, or is that just a Kuiper Belt objects? There's a lot of controversy about that. So I think understanding it more from as many diverse perspectives, spectrum, intensity, understanding its orbit, and searching for it with as many different panoptic capabilities, that will inform us better than almost anyone could do alone. And now you have to add to that theoretical investigation and modeling and simulation. As I said, solving the three-body problem is thought to be impossible in classical mechanics. Constantine is working on like the 20 million body problem, and he's really amazing. So look for those conversations to heat up.
He is one intensely smart dude, and I think he's got the best shot at getting us there. Let's see. Did you have another question on your end that you wanted to bring up, Ryan? I know I've got several of
Uh,
mine.
no, why don't we take one from yours?
Okay. I think this, well, actually, Dennis Polyakov pointed out right now, I think less than 5% of scientific applications pass the approving board and get telescope time. And then he goes on to add that he was referring to the Hubble Space Telescope. Yeah, you're right. Hubble is very oversubscribed, again, for a old obsolete telescope. It's the one that people want to use more than anything else right now, and um but oh yeah, and I guess I should also just mention, we talked about this in the comments before, but so everybody knows, Hubble is officially not yet back in business, but we expect it to be back in business, back on sky, as we call it, doing science. Could be as early as the end of this weekend. Some wonderful
Mm-hmm.
news, great development. They've actually flipped over to the opposite side of the electronics on the payload computer. And I
Mm-hmm.
did make a video about it where I went into some of the gory engineering details, because I can't help myself. I just nerd out on stuff like that. But they're in the best hands over there with HST. I mean, they've got some serious brain power. We also have a big hello from South Wales. Hey, biker boy Wayne One.
Nice.
Hello from South Wales. Good to see Wales in the house. How you doing? Okay, let me just double check, see if there's any other questions here. I think. Oh, and Johnny was asking, can data from the Gaia mission be used in search for Planet Nine? Brian, do you have any knowledge of that?
Guys are astrometric, looking for parallax measurements. It did collect, a billion images of stars. It would be hard to believe that there's nothing lurking in there. On the other hand, space is quite large, and we have this image from the, console video game Asteroids that I wasted probably 1,000 quarters on or more in my youth. That it's kind of like just rotten. It's like a junkyard, and you're trying to get through it, and people are shooting shotguns at you. It's not really like that, especially once you get out of the plane of the solar system, where most of the Gaia observations and the plane of the galaxy is where most of the observations take place, which isn't aligned with the zodiacal band. So it could be that it is lurking in there, but it's certainly, there's so much richness in that data set from the dynamics of stars, celestial mechanics, orbiting. But way back when, it was thought that you could actually have dark matter be caused, the actual responsible entity for dark matter, not some exotic medium like an axion that I've talked about with Frank Wilczek on the channel, or modified Newtonian dynamic, but it could just be machos, massive, complex halo objects, which was contradistinction to WIMPs, which are somewhat falling out of favor in some spaces.
Yeah.
This WIMP miracle may turn out to be a WIMP nightmare. But anyway, we really have kind of lost the hope that these machos could really play a role as a dominant form of dark matter, and yet we know they're there. And these could be basically objects around other stars that are like their Kuiper belts or their Oort clouds or whatever. So yeah, there could be stuff in Gaia for sure. I'm not entirely familiar with it, but I think it is a promising thing to look for.
Absolutely, yeah, I would agree. I mean, you should expect there to be some astrometric results. The question then is, how sensitive is Gaia? We're probably are looking at something that is going to be the brightest in the infrared part of the spectrum. Gaia is mainly an optical instrument, but if
Mm-hmm.
it's got an optical signature of any kind, there's a chance, that it maybe there is a little tiny bit of noise in the Gaia data waiting to be teased out.
Yeah.
Um, we also have hello from Australia. Good morning to you in Australia, where, as I understand it, you are in the future. So please tell us how the rest of my Friday evening is going to
No,
go,
what the
since you're
lottery is?
already.
What are you talking about? Get the
Yeah.
lottery
Oh yeah.
number.
What's the lottery, man? Help us out. Okay. Good to see you. We have so would any of you be surprised? Johnny Cheese is asking, would any of you be surprised if Planet Nine turns out to be a primordial black hole?
Mm.
Yes, personally, I would be very surprised.
Mm-hmm.
Which is not to say that I don't think that these things cannot exist or ever could exist. I would just be surprised that they were so ubiquitous that we even happen to have one. That's my hot take on it. Brian, how about yourself?
Yeah, I agree. There's very little evidence. It's hard to falsify because anything gravitationally bound can mimic the, or gravitationally massive can mimic the effects of an ordinary material body like a small icy rock. But there's, and indeed, Ed Whitten, none other than the kind of smartest man believed to be alive in some circles. He commented on this about a year or two ago that Planet Nine, you could actually detect that Planet Nine is a black hole by sending out a small spacecraft near the speed of light, and then sending out a companion, a millisecond later, or basically two spacecraft sending time delayed signals, and you could look for Shapiro delay, other types of phenomena in general relativity that would be indicative of a truly point-like or singularity type entity, rather than just a massive distributed body like a small planet. So those are people think about those things for sure. That is an interesting avenue to pursue.
Yeah, that sounds like a very cool experiment and something I'd never considered. But then again,
It
you know
takes a
what? There's
century,
a
though. It takes a century to
Yeah,
do it.
it does. Well, there's actually a good reason why I haven't considered it, because I'm not smart like Ed Wooden. That's the thing. The guy is super clever. Let's see. Oh, and videographer experience points out, and this was a reference to our conversation about Hubble. Two space telescopes mean double the observing time. Yeah,
Mm,
actually, that's a really good point, videographer, because uh, one of the key things. I mean, this is yeah, Hubble. Look, Hubble's old. I mean, it's 31 years old. We may. No one has a crystal ball, but we're kind of hoping now with this switch to the electronics will be good for another maybe 5 years or so,
yeah.
maybe longer. And so the real hope is that there will be some overlapping observations between Webb and Hubble. Keep in
Hmm.
mind, Hubble is primarily optical, Webb is infrared, and it'll be great to aim both barrels at at a target and get that kind of panchromatic coverage. So that would be super cool. We hope.
Yeah.
Um, yeah, that's I think it's entirely likely we will see that at least for a little while. And then there's a paper. Boy, Planet Nine is really getting is the sexy topic. Brian. I
Hmm.
don't know why you and I are here today. We should have had just Constantine get on both of our channels and just go. We could have had an early dinner. But anyway, there's a paper from last year that claims that Planet Nine is just an observation bias, spending more telescope time looking at the detection where we assume those objects are.
Mm.
Yeah, there's that, and I don't want to get into he said or whatever, but yeah, there's a paper that came out, and then there's people like Mike Brown and Constantine who say no, it's not an observation bias. So, I don't know. That's above my pay grade. So I don't know if you have any thoughts or not.
Yeah. No, no, I think that's accurate from my
Yeah.
perspective too.
So Brian, what do you got? Do you have anything on your end?
Uh, yes, that's right. So yeah, we're getting another question about about using the solar system objects like the moon as a base for future observational technologies. In particular, in my field, Joe Silk, who's a pioneer titan in the field of primordial perturbation theory, work with Stephen Hawking, is the father of so-called silk damping. He's a cosmologist now at Johns Hopkins. He has an idea for a low-frequency radio telescope on the moon, on the dark side of the moon, because of radio interference, not from OneWeb and SpaceX and stuff, but from from garage door openers, from whistlers in the atmosphere, from AM radio, ham radio, and there on the backside of the moon, it's very stable, it's very dark, radio dark, shielded by 11,000 kilometers of lunar dirt. So I think that could be a promising place for a telescope. For other things like LIGO or gravitational wave observatories, the moon has moonquakes. It has some kind of not tectonic activity because we don't believe it has such plates. But nevertheless, it has an active moonquake type surface. It has micrometeorites raining down on it, big meteors raining down on it. It's not the ideal place that people think. And actually, even the lunar circular collider in some parts, the two, would go over like between mountain ranges on the moon, and it would have to like send the beam through a tunnel that would be suspended over a valley on the moon like this. And so actually Beecham said, oh, the vacuum is pretty good on the moon's surface, so just shoot the particles across the chasm there, and they'll bridge the gap just fine, as long as it's not, the curvature is not too great and you're not trying to go too far. So actually having an open tube particle accelerator really reduces the cost, because a lot of the cost of the LHC is building the vacuum. The
Yeah.
magnets, etc., are very expensive, and superconducting them. But actually, part of the moon would be really cold. So yeah, telescopes on the moon. Other places in the solar system are less I'm less sanguine about. But yeah, I think there are prospects. So Christian, we're coming up on the end. I am going to go and dip in the
Sure.
Pacific Ocean. I know you are going to go into the Atlantic Ocean soon. And I do want to ask you the thrilling 3 questions that are patented on my channel, where, as I say, I talk to 9 Nobel laureates. I have a book coming out. Did I tell you my second book is coming out, Christian?
No, I didn't know that, Brian.
Yeah, I've got a new book. It's called Into the Impossible, Think Like a Nobel Prize Winner. I took all 9 interviews with the Nobel laureates, and I put them together, edited the conversation, distilled their wisdom into actionable advice of their habits, their tactics, their tricks and traps. And I actually got Barry Barish, a co-recipient of the 2017 Nobel Prize, to write the foreword. And he kind of inspired me to write the book and put it into print. I hope this will be a continuing series as I get more and more
That is so
Nobel
cool.
Prize winners to come on the show. But anyway, I asked them all these questions, and I'm going to ask them to you because you are, in this portion, my guest. And the first question involves the near future for yourself personally. So there's a tradition that a righteous person lives to 120 years old. So when you get there, you're about a third of the way there, probably maybe a quarter of the way there. I don't know how old you are, but you're going to get there, 120. When you get there, what piece of ethical wisdom do you want to leave for future generations to adhere to?
Um, be kind. I know that
Nice.
sounds trite, but we all are human and we are all going to have our bad days and we're all going to get frustrated and so forth. But sometimes you got to work a little bit at it. You got to think a little bit before you speak. You got to think a lot before you send that email, especially before you hit that tweet button. Um, you know, Look, we're living in an age where instant communication and fighting it's never been easier to fight with somebody, and we are seeing the consequences of it. I don't have to tell you what they are. I mean, it works everything from contesting elections to losing faith in democracy to you know you know accelerating our own extinction. Um, we got to get out of that. And
Yeah.
if we could just practice a little bit more kindness, I know it sounds kind of trite, but like I said, if we could practice a lot more kindness,
Hmm.
do that. And I'm inspired, of course, by Mickey Hart of the Grateful Dead over here, who at the end of the Fare Thee Well concert said, "Please be kind," and that always resonated with me.
Yeah, and stay curious. He said that, I think, too.
He did say
Uh,
that, yes.
yeah. Next question involves the deep future of the universe, and it harkens to 2001: A Space Odyssey, based on the book by Sir Arthur C. Clarke, which is the namesake of the center that I co-direct at UC San Diego, the Arthur C. Clarke Center for Human Imagination, where I'm the co-director. He said, or he had in the Sentinel, these kind of ominous, we don't really know what they were. These are obelisks, monoliths, etc. I like to think of them as time capsules meant to be discovered when the discoverer has reached the intellectual and cognitive maturity necessary to decode what is embedded within them, on them, of them. I want to ask you, Christian. Feynman said that the most dense, in terms of information, the most dense sentence is the atomic hypothesis that everything is made of atoms, and atoms are made of quantum mechanical elementary particles. I want to ask you, what sentence, what knowledge, what learnings in astronomy have you gleaned that you think represent the pinnacle of human civilization?
Wow. I That is a very profound question, and as you were asking it, an answer immediately came to my mind, but I actually don't think it's a direct quote.
Okay.
But I'm going to go ahead and use it anyway because it's attributed to Carl Sagan, who said, "Somewhere something incredible is waiting to be discovered."
Mm-hmm.
Now, what does that have to do with human civilization? It it means that there's, no matter what level of greatness or self-aggrandizement we may reach, there's still something incredible waiting to be discovered. There's still something more we need to reach for. It's a reminder that we still don't know as much as we think we do. That there's the Carl Finger puppet right there. Yes, you can
Yep,
see
you got to
it.
bring him out. I
And
had
I
on
think
his widow and his daughter have been on my show. Yeah.
it's this guy, folks. Watch his channel. He gets the coolest people on here. But
Yeah.
again, that quote is something that's also resonated with me because yeah, no matter how much we think we know, we need to keep reaching. And if there's anything that I would love for somebody to find in our monolith would be something along that quote, something that described that no matter who these people were or how great they thought they could be, they still were curious. They still stayed ever curious. And I think that is probably the best thing about being in the universe. We are a way for the universe to know itself. Once again, to invoke Carl Sagan.
Yeah, exactly. And the final question involves going backwards in time, and actually the name of this podcast, of my side of the podcast, Into the Impossible, and it's based on Sir Arthur's famous laws. One of which is for every expert, there's an equal and opposite expert. My wife trots that out on numerous occasions. Another law is that any sufficiently advanced technology is indistinguishable from magic. And the third one is the only way of discovering the limits of the possible is to venture beyond them into the impossible. And that's the name of my podcast. I want to ask you, as a young fellow, if you could travel back in time via wormhole, via black hole, some other kind of hole, if you could do something like that, what advice would you give to the 20-year-old version of yourself? Advice to your former self, please.
Hang in there, man. um, I've been through. I left the field for a while, went into tech. got fired from every job I ever had and outside of astronomy and came back into my field. No, I guess the thing is like that's tongue in cheek. Here's the thing. Here's the thing. I would say to myself, hang in there. It gets so much better. You have, no idea, and just believe in yourself. And I
Mm.
think that we can take that advice to fault. People think sometimes they're greater than what they are, and I'm not suggesting that we say that. I would tell 20-year-old Chris, I would say, hey, just believe. You're going to make it. There are great things ahead for you. Hang in there and stay curious, and you'll be all right. And I like to think, by virtue of the fact that I'm not all right, then I must be all right.
Very, very nice. Well, it's been a thrill to do this crisscross
It has
applesauce
been.
crossover, and congratulations and mazel tov on your
Oh,
100,000 subscriber primary
oh.
mirror. Can you show us that? Can you just give me the glimpse of it? I'll never get it, so I'll get a
Oh, yes,
glimpse
you
of it.
will.
I
You'll
want to
get it
glimpse it.
next.
Not at
All
this
right.
rate. This rate is like slower than the expansion of the universe, but
Oh, come on. All right. So folks, I'm sorry. I feel kind of weird doing it. It looks like
wow,
this.
look at that.
It looks
And if
like
you point it
this.
at me, then I'll finally be able to look at myself in a shiny YouTube plaque.
So now you can see what I see if you look in my mirror.
Wow,
But anyway, I'm very
you earned
grateful, and
it.
I gotta
You
admit
earned it.
when well, thank you, Brian. I have to admit when I got this, the very first thing that came to my mind was my mom. I know that she was my biggest cheerleader, and she would have been so proud of that. She would have been more excited about this than I was actually, and that's not an exaggeration. So, um, but yeah,
I knew you
believe.
when. I knew you when you had 56,000 subscribers about a year or two ago. You were gracious enough to have me on for some reason that I will never be able to repay you. And I
Oh,
do want to thank you so much and encourage my viewers to subscribe to Christian, get him to 200,000, get him to a million, get him
and
beyond into the impossible.
and folks, check out Dr. Brian Keating. Check out his YouTube channel. It is wonderful. You will hear just one amazing, mind-blowing conversation with a true intellectual, accepting today's talk. But you'll be so surprised at the folks that he gets on his show on a regular basis. You know why? Because he's damn smart, folks. He is absolutely well earned it. And you know what? He's a year from now, we're going to be celebrating his. Actually, screw it. At the end of this year, we're going to be celebrating his silver play
Hey,
button.
you're
I
making me
know it.
blush. Look, I'm
I
blushing now.
know it.
You're making me blush.
And
You showed me
also
how to do it.
subscribe to the Into the Impossible podcast. Oh, thanks everybody. It's so cool
Thank
to
you
to
so
see
much,
the.
Christian. It's an honor. Have a great weekend, everybody. Raise a pint to Chris, and wherever you are, remember my motto is "Stay curious, my friend." And Chris, what's your motto?
Oh,
ABC.
ABC, always be curious. Yeah, right. We're trading mottos today. So yeah, I know we haven't talked about Virgin Galactic and Blue Origin. Sorry, it's an hour show. What are we gonna do? But we will be back, and we'll have some more because of that. And yes,
Uh,
UK man says I subbed because you explained physics clearly. That's to you, Brian. Nicely done.
oh, very nice. Thank you, guys. Thank you so much, Christian. Have a great weekend. I'll talk to you all later. Bye, everybody.
Thank you, my friend. And I know Brian has a hard